Welcome. Just making sure that you're all in the right room. This is the session on 62443 and IIoT. Yeah. Okay. Just making sure. So, welcome to this session. I'm Ryan Dsouza, and I'm a principal solutions architect at AWS. It's a real pleasure to be with you all here today. And the topic I'm going to discuss is 62443 and how to apply it to IIoT, or the Industrial Internet of Things. In this session, we'll be going over some of the changes in the standards, as well as the certifications. We've got really a lot of content to cover, so let's get started. So as most of you know, or most of you are aware, industrial IoT is used across industries. These are some of the industries that it's used in. It gets introduced into the OT environment. So industrial IoT or IIoT devices integrate into the OT environment. And you do that when you implement industrial IoT use cases. Throughout this talk today, I will be discussing and talking about OT devices as well as IIoT devices. And just to level set, when I mention OT devices, I mean traditional OT devices like PLCs, HMIs, SCADA systems. When I mention IIoT devices, I mean modern IIoT devices like IP-based cameras, secondary sensors, as well as edge gateways. These IIoT devices get introduced into the OT environment when you implement industrial IoT use cases. So what are these industrial IoT use cases? Here are some of them. It's improving operational efficiencies in the factory. Okay, reducing unplanned downtime with predictive maintenance, improving product quality, supply chain improvements and supply chain management, as well as creating new revenue opportunities for manufacturers with smart products and services. Let's go ahead and take a look at the evolving manufacturing data landscape, and I've tried to lay this out based on ISA 95 and based on 3 different time zones. Okay. So the first time zone we'll take a look at is yesterday. In yesterday's world, you had asset owners that implemented the traditional para model or ISA 95 model. Okay, in this model, you had standalone applications, you had data silos, very little connectivity between the different layers, and few connections to external networks, right? So that's the yesterday scenario. Let's go ahead and take a look at what's happening today and tomorrow. In the today-tomorrow time frame, what we have over here is the introduction of IIoT. So the ongoing convergence of OT and IT and the introduction of industrial IoT into the OT landscape. What is also happening is that in the same way that the cloud transformed the IT landscape, the cloud is transforming and revolutionizing OT in new ways in what is called industrial digital transformation or Industry 4.0. What's going to happen in the future is even more convergence, continued convergence of OT and IT. Okay, I would say full convergence of OT and IT with any-to-any communications. In this scenario, you have digital factories and smart factories. This trend is going to continue. This trend is going to accelerate. There's nothing stopping this from happening. What is slowing this down is security, right? So security is one of the factors that is slowing down this transition towards a full convergence. And understandably so, because asset owners need to secure OT when doing IIoT and cloud projects. So this convergence of OT and IT introduces new opportunities for manufacturers, for industrial digital transformation, for Industry 4.0. But it also introduces new risk, which needs to be properly managed. Okay? If you look at this architecture over here, it is drawn out to the ISA 95 model. What IIoT introduces is new connections. So you can have IIoT devices at different layers of the stack, establishing connections to external networks or untrusted networks. And when this happens, you increase the attack surface. Okay? So this introduces new risk into the environment, which asset owners need to be aware of and need to be able to protect the full attack surface. So let's go ahead and look at the IIoT threat vectors. These threat vectors are not unique to IIoT, but they do exist with the industrial Internet of Things. Okay, and essentially, an IIoT device can get compromised or may be compromised and may be then used for a denial of service attack. An IIoT device can lead to lateral threat escalation on the network. It can lead to surveillance of the network. An IIoT device can lead to sabotage attacks on operational technology. Some of these devices are pretty powerful, right? Some of these edge computers are powerful devices. And if compromised, they can be used for cryptocurrency mining activities. Lastly, the data on the device or the data on the edge gateway can get encrypted, leading to a ransomware attack. Okay? Or you could have data that is being exfiltrated from the factory. Once again, these threat vectors are not unique to IIoT. What is different is that these devices, when introduced into the OT environment, significantly increase the attack surface, which needs to be protected. The consequences of a compromise is also what is different, because if there is a compromise, it can have environment, health, and safety implications, as you're well aware. So I'll give you a second to read this view of Little Bob, what Little Bobby has on the 62443 standards. So what I am going to add is that 62443 is comprehensive. It's a comprehensive set of standards. It also is consensus-based. And it can actually run into thousands of pages, right? Thousands of pages of guidance, which makes reading all of this a challenge. In order to level set on 62443 and the standards, so that we are all on the same page, it is a series of security standards for industrial automation and control systems. It was jointly developed and supported and managed by ISA and IEC, and therefore it's called ISA IEC 62443 standards. It is structured into different groups, and you can see the groups over here. So you have a general category, you've got policies and procedures, components, as well as system. It is important to note that these standards predate IIoT, right? So they were written before IIoT came into existence. And therefore, IIoT is not already represented in 62443. That needs to change, and that's one of the challenges. So let's go ahead and take a look at the challenges with using 62443 for the industrial Internet of Things. The first is that it predates IIoT, so it came basically before IIoT, and therefore, the standards need to be updated. IIoT introduces new communication channels into the OT environment, but also brings in lots of new functionality which asset owners can take advantage of. There are different roles in 62443. So there is the asset owner role, there is the product supplier role, there's also a service provider role. There is no formal role for the cloud provider, okay? So that needs to change. A recognition that a cloud provider can play a role in 62443 in the IIoT environment. And that's one of the changes that needs to happen. Many of the requirements that 62443 has does actually apply to cloud providers, okay? So it's not that, so there are some changes that need to be made, but many of the requirements already apply to a cloud provider. 62443 considers a segmented environment. So it considers their segmentation, it considers their perimeter-based security. Guess what? When you have IIoT and you have these connections coming in from that IIoT introduces into the OT environment, and if you look at the Purdue model, you've got these connections to external networks and untrusted networks. Okay, so network segmentation is important, but perimeter-based security alone is not sufficient. You really need to get into a zero-trust security model, because now you have these incremental connections that are at different layers of the OT stack that have connections to external untrusted networks. IIoT upsets the traditional para model, and we took a look at that in one of my earlier slides where I showed you at different layers of the Purdue model, you can have IIoT devices making connection to external untrusted networks. So what's actually changing in the standards? This is one of the important changes that you will see to the standard. It is the TR, or Technical Report 62443 4-3. This was jointly created and published by ISA 99, Working Group 9. I'm part of that committee. And they published this technical report. It's called 62443 4-3. It's also available as an IEC PAS, 62443 4-3. It is yet in draft, so it is not yet part of the standards, but it will be. It discusses the application of 62443 to IIoT. And in my view, it's a great document for asset owners because it provides asset owners with prescriptive guidance on introducing IIoT into OT environments and yet following the 62443 security standards. Security concepts like zones and conduits have a new meaning for IIoT, and we'll take a look at that momentarily. There is a section in the document that talks about the special considerations of using IIoT with cloud-based services. The document has no normative content, so there are no obligations. And also this document has got guidance, but no technical requirements. The technical requirements have not yet been written. And that's one of the ongoing works for the standards. So we'll now transition and take a look at using zone and conduit models. Those of you in the room that have used 62443, this should not be a surprise. These are zone and conduit diagrams. They follow 62443 3-2 for risk assessments. This is a really simple example where I have a secondary sensor connected to, in the OT environment, connected to an asset. So it could be a temperature sensor or a vibration sensor. It is connected to an industrial IoT gateway. This gateway then establishes a connection to an external network or an untrusted network like the internet in order to get connected to cloud services running remotely. Okay, so this is really a simple use case. In this use case, we're using the zone and conduit model. So you've got different zones. You've got the local zone, you've got an edge zone, and you can have multiple trust zones in the cloud, as you can see right over here. This zone and conduit model diagrams are very useful even for industrial IoT use cases in order to understand threats and vulnerabilities, right? In order to then inform your risk as well as understanding consequences. So we briefly spoke about this earlier that 62443 has got standards, roles. These roles are the asset owner role, the product supplier role, the service provider role. There is no role for cloud provider, okay? And the cloud provider can actually play multiple roles, multiple existing roles that 62443 has. So for example, the cloud provider can be a product supplier. Why is that? Because cloud services is the product. The cloud provider can also be a maintenance service provider. And why is that? Because the cloud provider maintains cloud services. And in some cases, the cloud provider can even be a system integrator if the cloud provider is playing the role of a system integrator on an IIoT project. So these are the changes that need to happen in the standards in order to recognize that there is a cloud provider and the cloud provider does play a role on IIoT projects and related with 62443. So when asset owners do use IIoT and introduce IIoT into their OT environments, there's always going to be cloud services. So it's important for the asset owner to understand what is called the shared responsibility model for the cloud. So what is the shared responsibility model? Essentially, it is defined as security of the cloud versus security in the cloud. Okay, so the cloud provider is responsible for security of the cloud, and the asset owner is responsible for security in the cloud. What does that mean exactly? So this is another view of what I just mentioned, where the cloud provider is responsible for the cloud infrastructure, right? The data centers, the services, the cloud infrastructure, that's the cloud provider's responsibility to secure that part of the solution. The asset owner, on the other hand, is responsible for security in the cloud, which means that they are applications, okay? They are OT and IIoT applications that they place in the cloud. Security for those applications and security of that data is the responsibility of the asset owner. The cloud provider does provide a lot of security services as well as prescriptive guidance in order to help the asset owner with their part of the responsibility. In addition to that, the cloud provider is continuously monitoring and achieving third-party validation for literally thousands of different compliance requirements, security compliance requirements. And the asset owner can take advantage of all of that, okay, because the asset owner inherits those security controls that are operated by the cloud provider. So we talked about the Purdue model and how the Purdue model gets upset. I do want to mention that the Purdue model is yet very useful, okay? And this is an example of using the Purdue model with industrial Internet of Things, with industrial automation and control systems. And this is the IIoT security architecture. It is aligned and it is based on the Purdue model. You can see the different layers or levels of the model at the bottom. So you've got level 0, 1, 2, and 3. 0, 1, 2, and 3, that's part of the OT network or the operational technology network. If we take a look at that, I actually have some details in this architecture, which is shown in different cells. So on the top cell, you've got PLCs or industrial automation systems that support insecure protocols. And in this security architecture, we're converting the insecure protocol to a secure protocol, right? So taking like Modbus or Ethernet IP and converting it to a secure protocol like OPC UA or MQTT, and doing that as close to the source as possible. I have a second cell there, and in that second cell, if you notice, I have a data diode or a unidirectional gateway in order to so that you can get data out of that cell without allowing anything to go into that cell. In my third cell, I've got modern PLCs, so modern industrial automation and control systems that support secure protocols out of the box. And the last cell at the bottom is an IIoT device in the OT network that supports secure protocols like MQTT. Between layer 3 and layer 4, I'm crossing the OT-IT network boundary. So level 4 and level 5 is IT and cloud. Between level 3 and 4, I cross the OT-IT network boundary. And I've introduced an IDMZ, or an industrial demilitarized zone, which can inspect all the traffic going northbound as well as southbound. You can there are different ways to establish secure connectivity to cloud services. You can see on the top, you can go over VPN connection. So you can have site-to-site VPN. You can have a private connection over direct connect. In addition, in the center, you can go over the public internet in order to connect to cloud services. On the cloud side, you've got different services that can ingest data, manage devices, store data, and build industrial IoT applications. In addition to that, the cloud provider provides security services in order to secure the edge, the industrial edge, and the cloud. So in the technical report 62443-4-3, there is a section in that report which talks about the security capabilities that cloud providers can provide. Okay, so when implementing industrial IoT use cases, the asset owner can take advantage of different security capabilities provided by the cloud provider. What are some of these capabilities? So you have connected asset inventory to manage your assets, your connected assets and IIoT devices. You have identity and access control. So the cloud provider provides mechanisms that every device, every IIoT device is given a unique identity with an X.509 certificate. And you can manage fine-grained policies using IoT policies. In addition to that, the cloud provider provides mechanisms in order to generate, rotate, and revocate credentials for your IIoT devices. Patching and software updates is super important and critical for IIoT devices. And these are capabilities and services for over-the-air updates. Securing the edge gateway. So in IIoT, you'll always have an industrial edge that consolidates the data, pre-processes the data, and then sends it off to the cloud. So you've got to secure the industrial edge, you've got to secure the edge gateway, and you've got to secure the credentials on the edge gateway. There are different ways, as I mentioned, to establish secure connections to cloud services, as well as secure remote access to on-prem resources. You've got to encrypt data, both at rest as well as in transit, and the cloud provider provides services to encrypt your data at the edge, in transit, in the cloud. Alerting and monitoring across the full attack surface, as well as alerting and mitigation. The ability to create a security data lake in the cloud and security analytics in the cloud can be provided by the cloud provider. And last but not the least is backup and recovery of OT data and IIoT data in the cloud. So the cloud provider provides lots of different services, very useful for asset owners to take advantage of when building and securing industrial IoT applications at scale. So let's transition to certifications. So ISASecure is the certification institute for 62443, and with that, we've got the first IIoT certification that is available today. It is the ICSA certification, or the IIoT Component Security Assurance certification. It is for IIoT devices. So these include IIoT sensors. They could be temperature sensors, vibration sensor, any IIoT device that establishes a direct connectivity to cloud services. Or it could be an edge gateway that consolidates data from multiple devices, processes the data at the edge, and then sends it to the cloud. So if you have any of these devices, an IIoT sensor or an IIoT device or an IIoT gateway, you can take advantage of this certification that's available today, okay, by ISASecure. Getting into some details on the certification, it is for devices and gateways. There are two certification tiers. You have the core tier as well as the advanced tier. It is based on 4-1 and 4-2, which is the component grouping of standards. It does have extensions as well as exceptions. In terms of extensions, it provides the ability for compartmentalization on the device, controlling software updates. So these devices need to have the ability to control and manage software updates, secure remote access to the device, strong methods of authentication using PKI, and we talked about X.509 certificates earlier, as well as component resilience to DDoS attacks. There is also a requirement for security maintenance audit in order to maintain your certifications. It's important to note that this certification, the component certification, does not include, does not incorporate, and does not have in it cloud services. Okay? So for cloud services, we've got the system certification. The system certification is yet work in progress. It is again going to be based on 4-1, 3-3, as well as 2-4. It's going to consider IIoT use cases. So one type of IIoT use case is data being sent to the cloud for visualization and analytics. A second type of use case could be a closed loop use case where you have command and control from the cloud down to on-prem resources. Yeah? So this certification, the system certification, is going to consider industrial IoT use cases. Most of the requirements that 62443 has does apply to cloud providers, as I mentioned earlier. And risk assessment and zone and conduit models can be used. We took a look at that earlier when I showed you a simple IIoT use case which used the zone and conduit model. So these are the two certifications, the component certification and the system certification, which is yet a work in progress. Finally, and I'm almost out of time, I'd like to end by saying that 62443, right, in terms of the standards, there's a lot in there that can support industrial IoT use cases. Okay, it really provides a strong foundation. There's no need to start over. 62443 can be reused and built upon, right? And the IIoT requirements can be added for 62443 to support industrial IoT use cases. New interpretation of 62443 concepts is needed. The new requirements that need to be added to the 62443 standards, and specifically the sections 4-1, 4-2, 3-3, and 2-4. It's important to note that the technical report that is published and the feedback that is received, that's going to provide valuable inputs to the different committees and the different working groups in order to go and create the technical requirements, okay, that then finally get added and incorporated into the standards. These certifications, ISASecure certification and IEC certifications need to be updated. New training materials will need to be added related to IIoT and 62443. And last but not the least, my view is that these standards and certification bodies need to move faster because this is happening. Industrial IoT is already used and will continue to be used in OT environments because asset owners need to improve and want to improve operational efficiencies as well as ensure that they continue to stay competitive. Couple of wrap-up slides in terms of ISASecure supporters. You have all the traditional industrial automation and control companies, but you can also see you've got cloud providers supporting the ISASecure standards, as you can see on the top right-hand side. And then finally, there's lots of good content and material, both in terms of the study reports as well as the IIoT component certification, and these materials are available, on these links. And the presentation, of course, is available to all of you. So with that, I want to wrap it up. It was a pleasure to give this presentation today. Thank you for taking the time to attend this presentation. I'm happy to take questions now. I'm going to be around for the rest of the week, so please find me and would love to chat. Thank you.